In the Cold War, a new age of innovation dawns. Fields of science and technology flourish like never before.
Really, for both the United States and the Soviet Union, both of these countries saw science and technology as critical to winning the Cold War.
Military-funded programs loop science and technology into a self-perpetuating industrial complex, meshing government, military, and weapons manufacturing.
All industry was built double use with a military capability inbuilt.
And science is welcomed into the corridors of power.
So it wasn't just the number of bombs that you might have, but the numbers of PhDs that you might have in a certain field.
The Cold War, a decades-long struggle between two superpowers and former allies, the United States of America and the Soviet Union. But beyond the ideological divide of capitalism and communism was a battle of another kind, one for technological supremacy.
And for each of these systems, science and technology were critical for how they were going to thrive and grow and bring prosperity and justice for their people.
Experimentation with nuclear power, innovation of weapons technology, exploitation of science capabilities.
The entire space program, you could argue, was a creature of the Cold War.
A race for scientific supremacy that lifts humanity beyond Earth's atmosphere, drags the world to the brink of nuclear annihilation, and launches decades of research into scientific and engineering marvels that continue to define the modern world. At the height of the Cold War, Soviet and American adversaries pursue the militarization of the science and technology industries.
Both the United States and the Soviet Union saw the Cold War as an ideological conflict between capitalist liberal democracy on the one hand and communism on the other. And so for each of these ideologies, science and technologies played critical roles in ideas about progress and justice and development. So under capitalism, you needed science and technology to drive economic development, and you also needed it as a system of rationality that would help voters make decisions and policymakers make choices. Under communism, ideas about science and technology were thought to drive a kind of progress that would allow all the people to benefit from the wonders of the future and from the wonders of modernity.
Cold War machines of war now travel faster, for longer, beyond the Earth's atmosphere and deep into the ocean. The nuclear age explodes with ferocious magnitude as governments raise the stakes, placing greater value on the role of science and technology in the war domain.
At the end of World War II, the leaders of the Allied countries really credited their success to scientific and technological achievement. Of course, the atomic bomb, but also things like radar and the proximity fuse. And so when they looked at everything that they had accomplished, and they looked at what the countries who had lost hadn't accomplished, they said, this is the difference. And they assumed that winning the Cold War was going to require the same kinds of technological and scientific insights.
July 1945. Vannevar Bush, director of the Office of Scientific Research and Development, sends a report to the U.S. President Harry Truman titled Science, the Endless Frontier.
This document worked from the assumption that scientific and technological achievement came from basic research. And so it argued that the United States should set up some kind of research system that funded basic research driven by, led by scientists, and that would lead to applications that would improve the quality of life for all Americans, that would drive economic growth, and that would keep the country safe, that would build military technologies as well.
Many ideas in his report helped lay the foundation for the creation of the National Science Foundation in 1950.
And they were convinced that this scientific research had to be driven by scientists, not the government, not military leaders. Now, in the post-war period, politicians didn't necessarily agree with that. And, this is a legitimate question. Were scientists running the show? Or were scientists available as advisors to answer the questions that they were asked and to only answer the questions that they were asked?
Despite this tension, politicians and scientists soon discover how mutually beneficial they are to each other. One such way is showing an increasingly distrustful public that atomic energy can be used for more than mass destruction.
The United States had a problem in the 1950s. which was that at the same time that it was trying to say it was the best proponent of scientific cooperation, its nuclear testing operations were coating the Earth with fallout. And so people were increasingly not trusting the United States.
If the public see that nuclear detonations yield societal, agricultural, or economic benefit, they might sooner accept continued nuclear weapons development and testing. September 1st, 1958. The Second United Nations International Conference on the Peaceful Uses of Atomic Energy, better known as the Atoms for Peace Conference, convenes on the shores of Lake Geneva.
The peaceful aims of the conference were naturally stressed by Mr. Hammarskjöld, United Nations Secretary General, proof that the nations can cooperate in this atomic age.
At the conference, several thousand observers, government officials, and scientists from the East and West meet to discuss the potential of using nuclear energy for peaceful purposes.
The United States wanted to send fissile materials, to share fissile materials with other countries, with the idea that the Soviet Union would also be required to contribute fissile materials to a kind of nuclear bank. This would simultaneously reduce the amount of fissile materials that the Soviet Union could use in its own nuclear weapons, but it also would show that the United States was a partner, that you could use radioisotopes in medical research. Maybe you could use it to drive agricultural research, to create new breeds of plants. You could build nuclear reactors and have electricity too cheap to meter, that the atom could be a source of bountiful good as well as this terrifying object.
As part of the Atoms for Peace program, the U.S. exports over 25 tons of highly enriched uranium to 30 countries to fuel research reactors. Critics of the program argue that this could lead to increased international nuclear proliferation. The U.S. hoped that the immediate benefits outweigh any future negatives. As nuclear experimentation continues through the Cold War years, the Soviets and Americans became aware of a growing necessity to show the public that nuclear detonations can benefit industries and economies.
Today, this scene of preparation for a peaceful nuclear explosion is at an experimental site. Tomorrow, when the potential of nuclear explosives is fulfilled, this scene will move to the site for a new harbor, canal, or mountain pass, a mine, oil field, gas reservoir, or water storage basin, or perhaps a new underground laboratory.
Originating in June 1957, the United States program Project Plowshare detonates 31 nuclear warheads in 27 different locations.
This is the peaceful potential of nuclear explosives that the United States is developing for all mankind. In the program it calls Plowshare.
In one case, an explosion displaced 12 million tons of Earth, sending a radioactive cloud of dust that rises 3.6 kilometers high as it travels in the direction of the Mississippi River. In the Soviet Union, their peaceful nuclear explosion program is divided into two projects with a total of 239 tests and similar objectives to that of the US. The largest detonation in January 1965 creates a 100-meter deep, 8,000-acre conical crater called Lake Chegan. The explosion sends a radioactive cloud into the atmosphere so large it is eventually detected in Japan. To this day, Lake Chegan remains radioactive. Peaceful nuclear explosion programs did little to assure public concern that nuclear power was anything but fuel for destruction. As protests regarding the testing of nuclear weapons continue, the United States looks to a growing scientific field to help with another technological problem: how to monitor and enforce nuclear test ban treaties. For this, they look to seismology, a scientific field that is transformed by the Cold War.
The thing about arms control agreements and testing agreements is the other guy lying about it? Is he testing nuclear weapons underground? So a lot of times, seismology was used to test the waves underground to see if they were using thermonuclear weapons or what you're up against.
One program supported by the influx of federal support for seismology is Project Vela, designed to develop new technologies to detect nuclear explosions in anticipation of a partial test ban treaty.
By electronic instrumentation, surface and subsurface measurements were made of violent shock effects in the immediate vicinity of the deeply buried explosion.
Project Vela includes seismic monitoring, and a nuclear testing detection satellite program for the Earth, atmosphere, and outer space. August 5, 1963. The United States, United Kingdom, and Soviet Union sign a partial test ban treaty in Moscow. It prohibits the testing of all nuclear weapons, but excludes those conducted underground. October 1963. Vela Uniform begins as part of Project Vela. It aims to develop America's nuclear weapons detection capabilities by conducting experiments to differentiate underground nuclear tests from other seismic events, such as earthquakes.
Seismology was sort of dragged into the arms race, what we call the verification angle. You can only verify a nuclear weapon two ways. Pick it up in the air, that is, you can pick up the radiation, or you can measure it with seismology under the ground.
As a consequence of the Americans and Soviets seeking to find stable ground with the test ban treaty, the field of seismology explodes. Funding pours in throughout the decade to the tune of $250 million. 1965. U.S. seismologists develop a system of linked seismometers, the Large Aperture Seismic Array. 525 seismometers distributed along geometric patterns, covering 25,000 square kilometers and using digital signals to transmit data, filtered and processed on high-speed computers. The Large Aperture Seismic Array's first objective is to detect, identify, and locate secret underground nuclear explosions. 120 data-sharing stations throughout 60 countries establish the worldwide standardized seismograph network. Seismology stations had been operational before this network was built, but now Cold War technology makes data collection more accurate. Directionally oriented seismographs, synchronized by crystal-controlled timepieces, feed seismograms onto photographic drum recorders. The American system is hailed as the finest system of global monitoring, but still lacks Soviet and Chinese data. The Soviets and their allies have their own network, the Unified System of Seismic Observation, in excess of 100 stations equipped with a variety of comparable seismic and data-sharing systems. Seismological technology adapted from the Cold War remains a constant presence, eavesdropping on the rumblings of today's Earth. In 2017, seismic data registered a nuclear explosion 16 times larger than the atomic bomb dropped on Hiroshima, one in a multitude of underground nuclear tests that North Korea has conducted since 2006. The field of seismology seized an opportunity to flourish during the Cold War. Another discipline taking the opportunity provided by increased funding into the sciences aims to increase the understanding of the Earth and its atmosphere. Meteorology. Advancements in the study of the Earth and global weather patterns grew out of the International Geophysical Year from 1957 to 1958.
This was a program that involved nearly 70 countries, large and small, very different levels of development, who were going to cooperate to gather information about the natural world. Things like the exact shape of the Earth, or maybe information about the magnetic sphere. Not coincidentally, many of these ideas could also be useful for national defense, which is one of the reasons that the United States encouraged it.
The International Geophysical Year was an important opportunity to begin making use of relatively new systems that were being refined, that had hot war significance and Cold War significance. And so you have systems like radar and radioactive tracers and computers, sounding rockets and satellites. All of these are dual use, both in the sense that they're military and civilian, but also in the sense that in learning how to better operate this equipment, you can learn more about the world around you.
Meteorologists within the United States Weather Bureau, such as Dr. Harry Wexler, had long championed the development of satellites to aid weather forecasting. Synoptic meteorologists hope that the use of television and infrared cameras placed on satellites orbiting the Earth will provide images of cloud cover, allowing more accurate predictions of weather fronts and warning of major weather events, such as cyclones. Yet, it is military advancements in Cold War reconnaissance satellites and an increase in funding of programs as part of the International Geophysical Year that ultimately make the world's first meteorological satellite, the Television Infrared Observation Satellite, or TIROS, possible.
The TIROS satellite had its roots in Army reconnaissance satellite capability. The infrared and the photographic capability have been developed by RCA and the Army Signal Corps after the launch of Sputnik and during the US's reevaluation of the Armed Service Space programs and consolidating it under the Advanced Research Project Agency, ARPA. They decided that they didn't need this extra reconnaissance satellite because the Air Force was already working on a highly classified reconnaissance satellite program. And so in response to that decision, colloquially, it's said that Wernher von Braun said, "So we'll look at the clouds."
April 1959. NASA takes over the TIROS project and gives the responsibility of analyzing data gathered by the satellite to the Weather Bureau. April 1st, 1960. NASA launches TIROS-1.
TIROS-1, which stands for Television and Infrared Observation Satellite, marks a new adventure in space, weather observation.
The satellite is 48 centimeters high, 106 centimeters in diameter, and weighs 122 kilograms. 9,200 solar cells cover an aluminium alloy and stainless steel body. On board are two 15-centimeter-long television cameras, one a lower-resolution wide angle, and the second a higher-resolution narrower angle. While only operational for 78 days, the 22,952 pictures produced by the satellite provide the first look at the Earth's cloud patterns from space, and are a vital step in the future development of monitoring global weather conditions.
Part of the significance of TIROS-1 was also determining exactly what could be seen from space and how detailed the images actually would be through the atmosphere, through clouds.
Despite the successful launch, politics hamper the goal of a true worldwide weather monitoring and communication system. In Cold War thinking, if observation satellites could capture scientific data, they might similarly track human activity.
There was concern that the images might actually be too detailed. The United States was already planning on circulating, they called them NEF analyses, the photographs that they would take of cloud cover. And so the release of the NEF analyses were actually delayed with TIROS-1 and 2 so that the United States could make sure that this was information that could go out. Another element of TIROS-1 and 2 is that they were launched in orbital inclinations that did not go over the Soviet Union so that the Soviet Union wouldn't have concerns about this being a spy satellite.
As improved TIROS satellites are launched, global weather patterns are captured and transmitted to meteorological ground stations on Earth.
TIROS-9 was put into a nearly polar orbit over the rotating Earth so that it can photograph the entire world each day. The satellite was programmed to take 400 pictures daily. Each day's coverage is converted to NEF analysis maps, which show the storm fronts all over the world. These are made available to weather forecasters for their analyses.
September 20th, 1963. President Kennedy addresses the United Nations General Assembly, proposing cooperation instead of competition in weather prediction and weather control.
It is therefore our intention to challenge the Soviet Union, not to an arms race, but to a peace race.
He proposes a global system of communication satellites to link the world via telegraph, telephone, radio, and television.
Weather satellites were still a touchy dual-use technology. It's a Cold War technology. And so gradually the tide begins to turn, and the United States begins extending invitations to the Soviet Union to collaborate on space experiments.
As East-West rivalries continue through the Cold War, scientists work to transcend that bitter divide.
The Soviet representative, he had a quote about how it was time to think about what the man in the street would value out of the space age. And weather satellites carried this promise for the ability to predict the weather reliably and track hurricanes and track or predict tornadoes. It had significance for industry, it had significance for societies, it had significance for maritime industries, aviation industry. This was something that cut across many different human activities during this time.
The spirit of international meteorological collaboration continues beyond the end of the Cold War. 2006. The Tixi Hydrometeorological Observatory is established as part of a joint Russian-US program. Built on a station initially established in 1932, the Tixi Observatory has kept records on the changing status of the world's polar regions and continues international research to monitor the Earth's changing climate. While the Cold War proved that science could be shared to benefit East and West, one covert area of research is explicitly engineered for destruction: biological and chemical weapons.
Chemical warfare training. Gases not on our schedule, but you've got to know how to face what they might be cooking up.
In the First World War, every major power employed chemical weapons on the battlefield, resulting in over 90,000 deaths.
So weapons of mass destruction includes nuclear, biological, and chemical weapons. But chemical weapons were seen to be used, and they had a terrible effect in the First World War. And you couldn't control them, not the way you can a rocket or a three-stage rocket or something like that. It didn't have accuracy.
In the Second World War, alternative delivery methods were tested. Germany used Zyklon B, a hydrogen cyanide in gas form, to exterminate Jewish victims on an industrial scale, the largest death toll attributed to chemical weapons. Allied nations such as Canada and the United Kingdom developed biological weapons programs that could destroy enemy crops and harm animals. During this same war, the Japanese tested biological weapons such as anthrax, cholera, and typhoid on thousands of Chinese prisoners of war. Into the Cold War, an arms race of a different kind to that of the nuclear one begins.
While there was chemical weapons, a rather big arsenal, and delivery systems in the Soviet Union. Well, they're developed because the argument was that the Americans are doing the same.
The Soviets and Americans massed enough of these weapons that should they be used, they have the potential to kill everyone on Earth.
Each country had laboratories that developed biological and chemical weapons. The story is that if these pathogens got out there, they would kill millions of people and there'd be no protection against it. I think that's absolutely true. Once you have research, the trick is to weaponize it, and then to find the technologies to deliver it. And during the Cold War, we had efficient methods of delivery.
1943. 80 kilometers from Washington, D.C., in the town of Frederick, Maryland, the U.S. Army sets up a biological warfare research facility known as Camp Detrick.
Here, men have pioneered in the conquest of the Earth's unseen killers.
Research and funding declines with the end of the Second World War, before expanding again with the onset of hostilities on the Korean Peninsula. The United States, fearful of biological or chemical strikes originating from the Soviet Union, begins simulating attacks on unwitting civilian populations. September 20th, 1950. The U.S. begins an 8-day open-air trial of a supposedly safe live bacteria on the citizens of San Francisco, without their knowledge or consent. They spray chemicals in 30-minute bursts, producing a cloud 3.2 kilometers in length, and collect and assess samples from 43 locations throughout the Bay Area. San Francisco residents unknowingly inhale millions of particles of the material released every day throughout the trial. The test concludes that it is entirely feasible to attack a seaport city with biological warfare aerosol. Later, it was discovered that while the bacteria was considered safe, it was responsible for the death of 75-year-old Edward Nevin and the hospitalization of a number of other civilians. 1952. As the Korean War rages, China and North Korea accuse the United States of dropping insects infected with anthrax, cholera, and typhoid throughout the Korean countryside.
Here is an investigating team come to examine a hut in Pechingse district, on the roof of which feathers were dropped by U.S. planes on March the 11th. These flies on the outside of the window of this farmhouse appeared out of season, immediately following low circling flight by U.S. aircraft.
Yet they, like their Soviet counterparts, have the means to conduct an attack and a history of testing. In future warfare, cruise missiles and unmanned aerial vehicles will offer more effective dispersal methods of chemical agents. But in the Cold War, as delivery methods are tested across a multitude of terrains, the Soviets and Americans explore inventive ways to launch biological attacks on both rural and urban populations.
What had changed during the Cold War was the way of delivering these things. You didn't have to deliver them in a tactical way. There are other ways to deliver things. So that made it very dangerous.
May 1955. The U.S. conducts Operation Big Buzz. The test studies the feasibility of producing, storing, and dispersing mosquitoes that could transmit a virus such as yellow fever. They store more than 1 million uninfected mosquitoes over a 2-week period and release over 300,000 from aircraft and ground-release munition systems. They survive the dispersal and are found as far as 600 meters from the test site. The experimentation is considered a success. Similarly, the use of insects to damage food supply crops or infect combatant or civilian populations is examined. February 18, 1956. Georgy Zhukov, Minister of Defense for the Soviet Union, gives a speech at the 20th Communist Party Congress. In it, he suggests a future war with the US will be characterized by the use of weapons of mass destruction, including the use of biological and chemical weapons. The US takes this to mean that the Soviet Union is in possession of these types of weapons, yet concrete intelligence on their nature and volume remains elusive. Within the Soviet military, opinions of the viability of this kind of warfare are mixed.
And their military, Russian military, are very kind of always mathematical. They wanted to have predictability, that if you use 100 nukes, you get that result, you kill that much people. And with germs, you either kill them or you don't. If the weather is sunny, the germs are killed, or if the people wash their hands and put on masks to cover their faces, they're safe. They didn't like it, they didn't buy it. So the initiative was coming from the biological industry, to some extent from the Academy of Science, that they were promoting these weapons, but not the military per se. They wanted predictability.
In the US, fears of Soviet advancements in chemical and biological weaponry leads to a significant policy change. Until this point, any implementation of this technology on the battlefield was permitted only as a response to an enemy's prior use. In March, the National Security Council allows for a first strike of chemical and biological weapons, but only if authorized by the President. The Army's Biological Research Center, Camp Detrick, is renamed Fort Detrick to symbolize the permanency of its mission. And covert evaluations of the effectiveness of biological material on civilians continues across the country. March 14th, 1968. 6,000 sheep are found dead in Utah. The sheep graze in pastures just 43 kilometers from the U.S. Army's Dugway Proving Ground, a facility testing a toxic nerve agent. The U.S. Army deny blame, suggesting death was caused by crop pesticides. Yet later, they pay compensation to ranchers. In the Cold War, as nuclear annihilation threatens the fate of humanity and proxy wars such as the one in Vietnam bloom, the pace of biological and chemical weapons research accelerates, and public consciousness grows ever more aware of the heightened danger of biological and chemical warfare as scenes of the Vietnam War are televised around the world. U.S. support of South Vietnam against the Communist North had been growing steadily throughout the 1950s. Foreign policymakers believe a North Vietnamese victory could lead to further communist gains in neighboring areas.
The Vietnam War, as important as it was to the United States and its allies, and certainly to South Vietnam, was a sideshow in the overall Cold War between the United States and the Soviet Union. It served as a theater for both the United States and the Soviet Union to demonstrate, to try out new technologies.
And in these proxy wars, the technological part of it was always the most important thing, because the proxy wars are not about kind of victory in the classical sense. The centers of power of both sides were shielded. I mean, no one bombed America and no one bombed the Soviet Union. I mean, the factories that produced weapons and the scientists who designed the weapons were all shielded. They were not part of the conflict.
January 1962. The United States begins Operation Ranch Hand in Vietnam. The operation's goal is to defoliate the jungle warfare environment, exposing enemy combatants and depriving them of food supplies.
The plane they use is the Provider, or C-123. Each one carries 1,000 gallons of defoliant. which is very like ordinary weed killer in common domestic use in America. It comes in 3 main types: Agent Orange, Agent Blue, and Agent White. If for some reason they're diverted from the DMZ, they can unload it on selected crop targets in other areas held by the Viet Cong.
Between 1962 and 1971, 45 million liters of a chemical agent, Agent Orange, described as an herbicide, is sprayed over the jungles and rural landscape of Vietnam.
It's cost them something like £3 million in weed killer alone. A big bill by American gardening standards, but in Vietnam War terms, only the equivalent of 2 bombers.
This toxic chemical compound strips 24% of the southern Vietnamese countryside bare. A toxic rain that mists down upon populations in over 3,000 villages. A further 28 million liters of agents white, blue, purple, pink, and green are also sprayed. The Agent Orange dose in Vietnam is estimated to be 20 times more powerful than what normal agricultural use requires. The Vietnamese population suffer ongoing health problems including cancer, diabetes, birth defects, and a range of intellectual and physical disabilities attributable to the extensive and extreme use of Agent Orange. As public pressure mounts around the continued use of chemical agents in the Vietnam War, 5,000 non-military scientists sign a petition of concern delivered to U.S. President Lyndon B. Johnson, calling for the U.S. biological and chemical weapons policy to be reviewed. November 25, 1969. U.S. President Richard Nixon renounces the use of offensive biological agents and weapons. He commits to destroy the United States' existing biological arsenal.
So you want to take some of these maybe volatile things off the table. And biological and chemical weapons would have been a natural progression for Nixon to use that as a bargaining chip to lock the Soviet Union into another treaty. Because in those days, Nixon is driven by Kissinger, who wants to lock the Soviet Union into a world in which they have an investment. And taking biological and chemical weapons off the table would have given them a sense of relief. You know, now we can concentrate on something else.
The pledge to not use biological and chemical weapons does not include the use of herbicides, which is added the following year. The final spraying of Agent Orange in Vietnam occurs in February 1971. At Fort Detrick, research into the defense against biological weapons continues. Additional parts of the complex are converted to medical research, such as the addition of a cancer research facility.
Where we have previously had scientists, some of the best people that we could possibly find in the United States, working on weapons of war, we now have scientists devoting their efforts toward saving life rather than destroying life.
The effectiveness of the secrecy surrounding the Soviet biological weapons program yields little intelligence for the United States to have a clear idea of their capabilities. Yet information about the nature of their programs slowly begins to emerge. July 30th, 1971, field testing at a Soviet biological weapons facility, located on an island in the Aral Sea, coincides with an unusual and deadly outbreak of smallpox in the township of Aralsk. For decades, the facility had been testing biological germ warfare agents, including microbial pathogens that cause plague and smallpox. The truth of the incident does not come to light until much later, when it is revealed that a crew member of a research ship became infected when the vessel passed within 15 kilometers of the testing facility. The containment response is swift. 50,000 residents are vaccinated, and travel to and from the port is temporarily suspended. April 10th, 1972, the United Nations opens for signature the Biological Weapons Convention, the first multilateral disarmament treaty banning the development, production, and stockpiling of these weapons of mass destruction. The United States, Soviet Union, and Britain sign. Eventually, over 182 other state parties add signatures. Missing from the Biological Weapons Convention are measures to enforce transparency and the prohibition of continued research. Being unable to inspect biological weapons facilities allows proliferation to continue unchecked. The Soviets and Americans suspect each other of continuing to develop and stockpile biological weapons.
At the same time, you need to have the industry that can mass produce, and you need, of course, delivery systems that will not kill them on delivery. And for that, you need tests, and they were making tests, and that was a gross violation. That was officially acknowledged in the beginning of '92 by President Boris Yeltsin. So we can quote him that really happened.
In the Cold War, a bond is forged between scientists and politicians, earning a rightful position of prestige within the corridors of the Kremlin and the White House. And as science and technology becomes more involved with politics and the military, these create ripples that will live on long after the end of the Cold War. As the Second World War concludes, the American public begin to crave what they missed during wartime rationing: vehicles and appliances. In the early years of the Cold War, American factories once dedicated to military production reconvert to civilian production.
After the Second World War, when, say, the American GDP going on defense reached up to 40%, and then swiftly decreased. But then came the Cold War, and for a long period of time, the United States was spending enormous amounts of money on defense. Russia, most likely in GDP percentage, even much more. It was an unprecedented militarization of both sides, especially the Soviet Union.
As the Cold War continues, government funding elevates science and technology programs which bolster military capabilities and advance political ideology.
And so throughout this time period, you have competing ideas about where should scientific ideas come from? Who should pay for them? Should we primarily fund science that's going to drive military outcomes? Or should we trust the scientists to research whatever they want in hopes that it might be useful later?
January 17, 1961. After 2 terms in office, U.S. President Eisenhower gives his farewell address to the American people.
We have been compelled to create a permanent armaments industry of vast proportions. In the councils of government, we must guard against the acquisition of unwarranted influence, whether sought or unsought, by the military-industrial complex.
And this term gave name to something that scientists had been worried about for most of the 1950s. Some people even call it the military-industrial academic complex. And that the military concerns had really overtaken not only scientific research, but vast areas of the economy. That the United States was no longer paying attention to investing in problems that would benefit the people as a whole. And that instead, so much of industry, so much of university research, that generally the public interest was all being funneled into military research and this conflict with the Soviet Union.
The potential for the disastrous rise of misplaced power exists and will persist. We must never let the weight of this combination endanger our liberties or democratic processes.
Fueled by the Cold War, a military-industrial complex emerges. Private manufacturers bid on lucrative government Department of Defense contracts to manufacture and supply the military with weapons and technology.
So in the 1950s and the 1960s, if you were an entrepreneur, particularly in the tech sphere, your best bet would be to apply for military contracts. This was guaranteed money. You didn't need to worry about finding investors. In some ways, you didn't even need to worry about whether your project panned out. You could get a federal contract, and this would allow you the freedom to develop the ideas that you had proposed. And the government bought into the system on knowing that many of these ideas wouldn't pan out, on the theory that some of them would. And the payoffs for the ideas that did pan out would be worth it.
The manufacture of weapons in both the US and Soviet Union escalates during the Cold War as proxy wars manifest in Korea, Vietnam, and Afghanistan.
Well, I was a scientist in Soviet times. I worked in the Academy of Science. I was not working on defense project per se, but the funding was coming from there. The Russian Academy of Sciences, 90% of its budget came actually from the Russian Defense Ministry. The Russian science, including academic science, was totally militarized. All industry was built double use with a military capability inbuilt. And that's why the Soviet economy was so ineffective. It was uncompetitive. The central planning was used to build it. But it was not the real culprit. It was the entire infrastructure of the Soviet Union was built for a big war.
In the Vietnam and later Soviet-Afghan War, the Soviet Union's military-industrial complex mass produces a tool of war that becomes the most sought-after weapon on the planet: the AK-47, or Avtomat Kalashnikova. Though designed toward the end of the Second World War, the AK-47 revolutionizes warfare. A simple design means affordable mass production. Its sturdy frame just as easily withstands the desert sands of Afghanistan as it does the muddy jungles of Vietnam. In Cuba, Fidel Castro is said to be fond of distributing engraved AK-47s as gifts. The present-day Russian military-industrial complex comprises of roughly 1,500 arms manufacturing companies, employing millions of workers, producing everything from armored vehicles to supermaneuverable fighter aircraft, unmanned aerial vehicles, and ongoing generations of the Kalashnikov rifle.
And still, even today, the Russian leadership, President Vladimir Putin, is implying that if we invest into military and industry, this will have a spillover into civilian. Well, that's not so. In today's world, it's the other way around. It's civilian technologies that are then may be used in military.
Out of the American military-industrial complex during the Cold War emerges a supersonic jet interceptor and fighter bomber, the F-4 Phantom III. Designed and manufactured at McDonnell Douglas, this highly adaptable aircraft is operational in the Vietnam War. Utilizing advanced onboard radar systems, it reaches speeds of over Mach 2 and is capable of carrying just under 900 kilograms of weapons. Similarly, the Soviet Union offer their own supersonic jet fighter and interceptor aircraft. The MiG-21 rolls out from a Soviet Union aerospace and defense company. Though operational since the early 1960s, the MiG-21 stands up against the US F-4 Phantom III.
It was not as technologically advanced as its American counterparts, such as the F-4 Phantom, but it was small and it was nimble. And so it was a very good dogfighting aircraft. And at least early on in the Vietnam War, North Vietnamese MiGs inflicted pretty heavy casualties on US Navy and Air Force pilots.
Out of Soviet and American Cold War military-industrial complexes, mass production of weapons escalates as both nations race to supply former foes and allies with arms. By the 1980s, though some proxy wars of the Cold War era had concluded, the Soviets and Americans were still engaged in bitter rivalry. 1985. US President Ronald Reagan is entering his second term in office.
Under Reagan, the Cold War heated up again through investing in science and technology. But there was a crucial difference from how things had worked out in the 1950s. During the Vietnam era, many universities had actively divested from doing military research. Many universities banned classified research on campus. And so military research was now most frequently conducted by defense contractors. And so when Reagan started investing again in military research, that so much money went to private contractors that we began to call it the Iron Triangle, with the 3 points being defense contractors, the Department of Defense, and Congress. Kind of an impenetrable set of funding techniques that would be resistant to criticism, impervious to expertise, and really impossible to shut down.
While the military-industrial complex builds America's weapons, where they are used, and more importantly sold, is a matter of controversy. Reagan promises to fight communist expansionism. The promise manifests in a deal involving Iran, hostages, American weapons, and a right-wing rebel group in Nicaragua known as the Contras. The Americans seek the release of 7 of their citizens, held hostage in Lebanon by the militant organization Hezbollah, a group with Iranian ties.
There has never been a minute from the first kidnapping on that we've not been doing everything we can. Our great problem is the secrecy, the inability to locate and find. Are they being held by one group altogether? Are they separated? We have reason to believe now from some of our intelligence gathering that they are being moved around.
Senior officials within the Reagan administration facilitate the sale of 1,500 missiles to the Khomeini government of Iran for a total of $30 million. Despite an arms embargo on the sale of weapons to Iran, officials hope that in exchange for the weapons, the Iranian government will negotiate the release of their citizens. When news of this breaks, Reagan initially denies any negotiations with Iran.
Our government has a firm policy not to capitulate to terrorist demands, that no concessions policy remains in force. In spite of the wildly speculative and false stories about arms for hostages and alleged ransom payments, we did not, repeat, did not trade weapons or anything else for hostages, nor will we.
He retracts the statement a week later.
The principal issue in contention was whether we should make isolated and limited exceptions to our arms embargo as a signal of our serious intent. I considered the risks of failure and the rewards of success, and I decided to proceed, and the responsibility for the decision and the operation is mine and mine alone.
Following an investigation into the weapons deal, it is discovered that $18 million of the funds are missing. Lieutenant Colonel Oliver North of the National Security Council comes forward to take responsibility for covertly diverting the funds to the Contras in Nicaragua. The Contras are engaged in efforts to overthrow the socialist Nicaraguan government. They are funded, trained, and supplied with weapons from the United States. Eisenhower had warned of the potential rise of misplaced power and the unwarranted influence of the military-industrial complex over a democracy devoid of public scrutiny. In the United States as of 2017, about 10% of the $2.2 trillion in factory output is dedicated to the production of weapons that are then sold to the Defense Department and used by the U.S. military. The ongoing legacy of the military-industrial complex can still be felt in the Russia of today.
And so when the Soviet Union collapsed, this resource industry separated itself from the defense industry that it should have served and began to sell it all on the world market. And a whole generation of Russian oligarchs made billions of dollars, first selling the reserves that the Soviet Union had accumulated, and then selling the new production. This experience of the Cold War, it's imprinted in the infrastructure of the country. We still have bad roads, but good railroads, because the railroad system was the main strategic logistical system for a war. Everything moved by railroad. Tank divisions would be moved from one theater or one part of a theater to another by railroad.
As of 2019, the United States and Russia remain the two largest suppliers of weapons throughout the world. The Cold War helped launch the atomic bomb and realize the potential energy of nuclear power. Once lesser scientific fields, seismology and meteorology, redefined and elevated humanity's understanding of the Earth, weather, climate, air, and atmosphere. Superpowers pushed to develop some of the most lethal biological and chemical weapons known to exist. As the military-industrial complex rose like a behemoth during the Cold War, the scientific community rose in stature within the corridors of power. But since the end of the Cold War, the international scientific community has been notably absent from those corridors.
So with the end of the Cold War, the fall of the Berlin Wall, the collapse of the Soviet Union, the US-Soviet competition stopped. And that driving force behind US technological development really lessened. So for the first 10 years after the end of the Cold War, the United States was essentially unrivaled. It was very difficult to make the argument that the US needed to develop more advanced technology. And then after the 9/11 terrorist attacks, we found ourselves in a different situation where we were dealing with transnational terrorism and where our qualitative advantage really didn't matter as much.
Yet, the lessons of the Cold War left a lasting impression on the way we look at science and technology.
In the United States, the legacy of the Cold War is all around it. We see it in the internet. We see it in contaminated soil and water left over from nuclear production sites. But we also see it in the institutions of science in the United States. Institutions like the National Science Foundation that continue to fund basic research in the United States came directly out of a Cold War context. This language that science should be free, that funding should be generous, that scientists should focus on basic research continues to animate much of the ways that we talk about science and technology today.